Okay, let's recap a second. So here I'm drawing some DNA. So we've got one strand of DNA. We've got that sides of the ladder that are made up of the sugar and the phosphate. And then in the middle, we have the rungs of the ladder that are made from having that Char-gas pair where we have G is paired with C and A is paired with T. So this is our original parent strand. Got two sides. So in replication, helicase comes in and it's going to just separate the two strands. Okay, so it comes in and it like busts through these and it pulls them apart. So then we end up having one strand on this side, one strand on this side as it's getting pulled apart with our nitrogen bases here that are separated. Okay, so we've separated. We've got a parent strand here and a parent strand here. So helicase separated. And then we talked about how primase is going to come and say, hey, this is where we need to start. And then DNA polymerase comes in and puts down the new side. So we end up adding a new side to each, putting in the appropriate nitrogen bases, and making two strands out of it. Okay, so that's our semi-conservative DNA replication. So what we end up with when this is happening, those parent strands that we originally separated apart, one of them we call the leading strand and one we call the lagging strand. So DNA polymerase can only put down this new strand in one direction. So it can only build from 5' to 3'. It's just the way it's set up. It just can't do it a different way. It has to do it that way. So primase tells it where to start, and it will just build until it runs out of things to build. But when it's building, it only can do it in one direction. So if here let's say we separated a strand and here's one side of it, okay? So let's say this is 5' and this is 3', because they have directions, right? Okay, well, if that was the case, we got to remember DNA polymerase has to go from 5 to 3. So if this is 5 and that's 3, when we're building the new one, it has to go from 5 to 3. So it's going to have to build this direction. So when it's doing that, it has to go from 5 to 3. So, and again, primase is going to come here, and then DNA polymerase is going to come in and add on our new complementary base pairs, our new nucleotides, and it's going to go ahead and build this new strand, right? With the appropriate nitrogen bases for each. But it only can do it from 5 to 3. Okay, but we've got two different strands, right? And they're going in opposite directions. So to figure out leading and lagging, what we're going to look at is this little picture here, okay? So again, we're separating the DNA. We've got 3 to 5 on the original parent, and then the opposite is going 3 to 5 the other way. So the leading strand is going to be the one where the DNA polymerase can just go. Primase tells it to start here, and DNA polymerase, it doesn't have to stop ever, it just goes. Okay, so it's just going to go, 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 go. So here's our DNA polymerase, and it just keeps going. On the other strand, it doesn't work the same way. Okay, because again, DNA polymerase has to go from 5 to 3. So on this one, it can't start where it originally opened up. It has to like start a little bit way in. So primase is going to come here. It's going to say, hey, start here. And DNA polymerase will go and finish this little section. But then this is getting opened up the whole time. So once it gets to here, it's run out of space to do anything. And it has to back up. Primase tells it where to go. And then the DNA polymerase jumps to another section and does it. And then more opens up and primase moves and we do another section. So it ends up that you have these little chunks basically. Okay, so let's look here. Okay, so we can see this happened, right? So primase told it to start here, it did that section. Okay, then more opened up, now it says, okay, start here, do this section. But it keeps like having to jump and do these little sections at a time. So each of these little sections is called an Okazaki fragment. So Okazaki was a Japanese scientist, and he's the one who discovered like this is the way it works. This is how we can do both sides of the parent strand and make a copy, use it as a template for it, but the one side has to do it in these chunks. Okay, so here we can see it again. We're opening up the DNA the other direction. We got helicase working here, this little green triangle. It's opening up the DNA. This leading strand, it can just keep going, and it'll just as helicase opens, it'll just continue to lay down new strands. The other one, our lagging strand, has to do it in these small chunks. So we call it lagging because it just takes longer. Because every time primase has to come and say, okay, come here, do this part, and then DNA polymerase finishes it, and then it has to wait for primase to tell it to where to go again the next time. And the other thing that happens is because we have these fragments, we have another enzyme that gets involved called ligase. So ligase is, we call it the gluer. So all these little fragments that we have are not connected. So you can see right here, like there's a small space. It can't quite stick everything together. So it's like you have a ladder where the side of the ladder has, basically holes in it. It's not super stable, we have to fix it. So ligase comes in and it glues those sections together.